Hello and welcome to Empowered Learning. This particular video will be about exponential functions and graphing them. And so we want to talk about the basic anatomy of what a exponential function looks like, what are its basic properties, and to translate those properties into what it would look like on a graph. So we start off by looking at the definition of what a exponential function is. And so we see that it's defined as f of x is equal to a raised to the x, where a is a number that is greater than 0, but it cannot equal 1. Okay, a is what is called our base for the exponential function, and of course x is our exponent, but it's also what our variable is. And so that's one of the reasons why this particular function is called an exponential function, is because the variable resides in the exponent. Okay, so we have the base defined as being greater than 0 but restricted to be 1. Okay, and one of the reasons for that is we know from our exponential rules that 1 raised to the anything is always equal to 1. So if we try to graph, any exponential number where its base is 1, it's just going to look like the line y equals 1, and that really doesn't make sense for us. So that's why we don't include that. So moving on here, if we were to look at the basic profile of an exponential function, we have two distinct situations. And so one situation is what we call exponentially increasing. And so that's this case here, where the graph starts down and it starts to curve upward, or exponentially increase. And we have exponentially decreasing, where it starts off high and then it goes low. Okay. Now, how we tell the difference in between whether an exponential function is increasing or whether it's decreasing is to know what its base is and or the exponent. And so you'll see what I mean by that. So in general here, you see that when we have y is equal to ax and our value for a is greater than 1, then that's when we have a situation of an exponentially increasing function. When our a is in between 0 and 1, like how I'm saying here, and so that would be this case here. And what we mean by a being between 0 and 1, in particular, we deal with this more so if a is what we call a proper fraction. Okay, and so proper fractions, in case you forgot, look like 2/3, 1/2, let's say 4/5, that kind of thing, where the numerator is smaller than the denominator. Okay, so that's what we mean by that. So go ahead and get rid of some of this extra stuff here. All right, so we know that if our base is in between 0 and 1, then the graph is exponentially decreasing. If it is greater than 1, then it is increasing. So to give you a quick example of that, let's say we wanted to look at the function y equals 5 raised to the x. Well, since a is greater than 1, then it will exponentially increase. Okay. On the other hand, if I come over here and I say let y equal 1/5 raised to the x, then of course that would be an exponentially decreasing function. Now, if you notice, anytime we have a base being in between 0 and 1, we can also express the exponential function with a negative exponent. And so that's true because, and let's just take 1/5 raised to the x as an example of that. We know that the quotient of anything raised to a particular power, we can just raise both the numerator and the denominator to that power. Okay, and so let me fix this x right here. Let me just do it over. So 1/5, and that's x, and that's x there. So 1 raised to the anything is always 1. And of course, we just have 5 raised to the x. And then, of course, 1 over anything could be expressed as that anything raised to the negative exponent. So hence we have 5 raised to the negative x. So this is where we get this saying that if our base is in between 0 and 1, then that's the same as having that particular base being greater than 1, but raised to a negative exponent. Okay. So in general, when we look at an exponential function, whether we have it kind of in this form or in this form, or even, as y equals some base greater than 1 but raised to a negative exponent, we can get a general idea of what the graph looks like. Okay. So moving on here, some of the key properties that we need to look at whenever we're dealing with an exponential function is, now that we know that it's either going to be exponentially increasing or decreasing, the next thing that we need to know is, all right, well, what are some key points that we can plot? And so in general, whenever we have an exponential function where its base is greater than 1, we could use these 3 key points here. And so if you notice, if a is in between 0 and 1, we have the same key points, but they're going to look slightly different. And so I'm going to use the example that we had here above to make my point. So let's say we have 5 raised to the positive x. We know that's going to be exponentially increasing. Okay. So if we look at this in terms of the key points, we know that our a, which is our base, is 5. So we're going to have -1 1/5, 0, 1, and we have 1, 5. Okay. So those will be our 3 points. So if we go back up here, and I'm going to get rid of some of this other stuff now. Try to make this a little bit more clear. So if we go up here now and we look at the graph that is exponentially increasing, we'll see that if I was to put a 5 in place of this, of course, this point here is always going to be the point 0, 1, and put a 5 here, then my graph would basically look like the profile of an exponentially increasing function, but it'll go through those 3 points. Okay. So if we look at the case where we have an exponentially decreasing function, we know that we could express it this way, or we could express it as 5 raised to the negative x. Then everything stays the same. But notice here that we're still going to have -1, 0, 1, but now our a is actually 1/5 now. Okay, so if we look at this, then hold on, something's not. Yeah, so here if we're looking at this, our a is going to be 1/5, and so looking at it this way, then 1 over 1/5 is going to give you 5. Okay, so 1 over 1/5 will give you 5. Okay, if you look at it from the standpoint of writing this as something raised to a negative exponent, then your a looks like it's 5, and thus you're writing it this way. So whether you look at it in terms of here where the a is greater than 1, or if you look at it here where your a is in between 0 and 1, and you rewrite it as positive, well, I should say the base being greater than 1 raised to a negative exponent, you'll see that you'll get the same thing here. Okay, 0, 1 is always there, and then for the last one we have 1/5 for our y. So the thing that I want to point out is that here the key y values here are the first one and the last one, which goes with -1 and 1. So if you notice for the case when the base is greater than 1, we have low y value, high y value. But then when we go for the case of when our a is in between 0 and 1, or if we have a negative exponent, you see we have high y value, low y value. And that's the main difference in between the two. And so we'll get some more practice here on the next page with this, but essentially just knowing that key points when x is equal to -1, 0, and 1, and then just plugging in your value for a accordingly will give you the points that you need for your graph. All right, so let's go ahead and look at some other examples here. So for 4 raised to the x, we see that our a is 4. And so we know that from this, it's going to be an exponentially increasing type function here. Here our points are going to be -1, 1 over a, which is 1/4, 0, 1, and then 1, 4. Okay. And so if you notice in this graph, you also see this little dotted line here that's going across the x-axis here. What this is called is a horizontal asymptote. I'm going to go back to the first page here to talk about that a bit. So here you notice that you see the same thing going on right here. And so what this horizontal asymptote is doing in this case is communicating to you that the graph of an exponential function in its basic form, like how we have it, whether it is exponentially increasing or exponentially decreasing, will not go below the x-axis. Okay, and so that means in the case of when the function is exponentially decreasing, that we can exponentially decrease as much as we want. So here, let's say, to get more concrete, let's say for y is equal to 5 raised to the -x, okay, or 1/5 raised to the x. I can plug in as high a value, positive value for x as I can, and I will never get to 0, okay? So that's essentially what that horizontal asymptote is saying here. For the case when we have 5 raised to the positive x, we can plug in negative values for x, get as low as we want, but we will never get to 0, okay? So we're bounded below by this horizontal asymptote. So that is the reason why you see these dotted lines here, and I'm saying y is equal to 0. So the function is bound by that, okay? So for example B, we have the same kind of thing here, but now we see that our base is in between 0 and 1. So to do that, we know that it'll be the same as what we saw here in example A. We just switch these y values. So since it's exponentially increasing over here, we go from low y value to high. And since it's exponentially decreasing here, we go from high to low, okay? So same y values, you just need to switch these. And of course, you see that the graph looks the way that it does. And so here, this point here, just to be clear, is the point -1, 4. This is 0, 1. And this one here is 1, 1/4. And over here, this is, get rid of that. This is -1, 1/4, 0, 1, and 1/4. Okay. Moving on to next examples here, we see that we have 10 raised to the x. And so since a is greater than 1, we know it's going to be exponentially increasing. So it's got to go up like how we see it, but it has to go through these 3 points. -1, 1/10, 0, 1, 1/10. Okay, so -1, 1/10 is about right here, real close to the x-axis. This is 0, 1, and of course that's 1/10, and we just connect the dots. For example D, we have 1/2 raised to the x. And so 1/2 raised to the x could be written the same as 2 raised to the negative x. Okay, so same deal here. Since we know that this is exponentially decreasing, we know that if we look at it in terms of the a right here, then we have the high y value go with the -1, the low y value go with 1. Okay, if you look at it in terms of this, where a is being greater than 1, if you look at it in that light and you look at these points, then you see if I take a 1/2 and I plug it in for a right here, 1 over 1/2 is going to be 2. So that's why I have 2 there. And of course, a, and if we look at it just generally like that, then a is going to be 1/2. And then, of course, that's why we see the 1/2 there. Okay. All right, so we're going to come up with some on our own now. So here we see that we have y is equal to 3 raised to the negative x, which we know is the same thing as 1/3 raised to the x. So in looking at this, we could come up with our points. We know it's going to be exponentially decreasing. So -1, 0, 1. Here we can write this as 3 raised to the negative x. So we want to have 3 here, 1 there, 1/3 there. And to plot those points, we know -1, 3. So -1 here, 1, 2, 3. 0, 1. And then 1, 1/3, which would be about right there. And of course, we'll have the horizontal asymptote at y equals 0. And we'll just do our best to kind of connect the dots here and draw our graph. Okay. Same kind of thing with y equals 2 raised to the x. Here we know that this is exponentially increasing because our a is greater than 1. So we have our values here. So exponentially increasing means low y value first and then high y value last. So we have a -1, 1/2, which would be about right here, 0, 1, and then 1, 2. And of course, we have horizontal asymptote, y equals 0. And of course, we'll just connect the dots here. So we'll kind of just do it like this. Okay. All right. And so for these last two, I won't speak too much. I'll just go ahead and just write everything out. We know that -1, 0, 1, since this a is greater than 1, this will be a situation where we have low y value to high y value. And then for D, we know that this is going to be exponentially decreasing. So when we do our key points here, we know that we're going to go from high y value to low y value. Okay. And of course, we can just take those points and plot it. And I'll just do that for both of these graphs at this time. So here, -1, 1/5. So I'll put that about right here. 0, 1 right there, and 1, 5. 2, 3, 4, 5. And so our basic graph would look something like this. No, it's not exact, but we get the point there. Okay. Same thing here. We got -1, 8. So that would be about right here. 0, 1 would be here. And 1, 1/8 would be about right there. And so, of course, this would swing up real fast and kind of look like that. Okay. So this pretty much gives us an idea on how to graph exponential functions, whether we have exponentially increasing or exponentially decreasing.